All right, everyone. Welcome. My name is Jake Wharton. I work at Google. I'm surprised to see so many people at a Dagger talk that was listed as advanced. I didn't tell them to make it advanced, but once I saw that, I didn't pull any punches. So this is going to be quite technical. How many people are using Dagger in their Android applications? Okay. If you're not using Dagger, this talk will be a challenge, so I'm not going to cover Dagger really at all. This talk is about libraries that are built on top of Dagger that allow you to simplify some patterns that come up in Android applications, and also around sort of the performance implications of Dagger. So I'm going to start with like kind of a weird on-ramp into this talk. I want to talk about words that get thrown around when we talk about Dagger, or really any library. And boilerplate is one that you hear. I don't know if it's all software development or just Android development, but this term gets thrown around a ton. And it has a very specific definition, which we tend to, like, we literally use it wrong in the literal sense of literally. What we usually mean when we talk about things that have boilerplate is that they have verbosity. We tend to say boilerplate when we mean I have to literally write any code that's boilerplate, which is not true. You know, code has purpose. And so, yes, Dagger has associated verbosity to it, but there's actually almost no boilerplate. Everything you write informs the Dagger compiler or runtime of something very specific, and because of the way that it works, there's not really a more efficient way of representing it in Java, at least. And so I'm going to use the word boilerplate in this talk, and I mean it in the defined sense of the word, where it's something that is repetitive, that can be automated. And then before I get too deep, I want to talk about why we choose something like Dagger. You know, the Android development is a rocky landscape, and if you go and start building little toy apps without any foundation, right, you're going to have a bad time. And so you hear things like Dagger from people in the community, and you think, maybe having not used it before, that it's the solution to your problems. And it can offer a solution to these problems of, you know, building the foundations of your app, but it is a heavyweight solution. And when you're building these toy sample apps, when you're trying stuff out, or even just small side projects, it may not be the right choice because it is built it's built to scale to everyone. And so when we talk about boilerplate with Dagger, usually we're talking about the verbosity associated with just getting a setup for Dagger working, especially one that's designed correctly. And that's why you see a lot of people turning to things like service locators, or even what I recommend for these things is just doing nothing, just doing manual dependency injection, because it doesn't matter at this scale. It's only when you start building real things does it matter what you choose. Manual dependency injection only scales to, you know, a relatively small app. Once something becomes serious, it really does have a lot of boilerplate of just passing things around. And so I'm not here to argue between service locators or Dagger, but service locators have an associated verbosity when they scale, whereas Dagger's verbosity, in terms of like the slope of how much it grows, the line starts higher up, but it grows much more slowly, whereas service locators start small and is going to accelerate quickly. So Dagger is just this foundation that you choose because you want something that's going to scale until you build bigger and bigger things. So I thought it was important to present that context because the things that I'm talking about here are not something that you're going to use once in an app, or if you only have, you know, one activity, one view. These are things that crop up through repeated usage of Dagger, through widespread usage in an application that's become non-trivial. The first one I want to talk about is about factories, the factory pattern. And so I tried to pick an example that would resonate with everyone, whether or not you do this presenter pattern directly. The idea is that you have a presenter for a screen. It has some dependencies that it wants from Dagger, but it also has like some state that's coming into it to inform the presenter what it's displaying. So this is a profile presenter. What profile am I looking at? And because Dagger is creating this object, we can't just add another constructor parameter for, say, the user ID. because we need Dagger to be able to construct it, but the implementation of the presenter also needs to know, which profile do I load with the profile persistence, what initials do I render in the avatar with the avatar renderer, and where do I download the profile URL, or through what dependency do I download the profile URL. And the way we like sneak this state into the presenter is usually, sorry, all the examples here are in Kotlin, but everything applies to Java as well. In Kotlin, what we would do is put something like a late in it, maybe just put a method, which is like initialize that you pass something into. But we sneak this state in, and we create this implicit contract now that you have to inject this type, but then also like get it ready, make sure it's actually ready to do its work. And so at the consuming site, the site that we have the ID where the person clicked on a specific user, we have to inject the presenter, but then remember that we have to set this little extra field before we start using it. So this is a dependency, right? It's the presenter depends on knowing this state, but it's not one that is a dependency in the way we traditionally think about it, and it's certainly not something that we're probably putting in the graph. We want this to come in through the constructor so that when you have a presenter, you know it's just ready to go. So we can do this in the graph if we want to. You see this a lot where people recommend, this is where like qualifier annotations start coming in. String is such a generic type, and so we say, well, just put the user ID in the graph. But that requires a lot of this verbosity from Dagger in order for that to work, because in order for this type to be in the graph, you're going to need a dedicated scope that user ID can live in. And that means a component, probably a component builder. In order to pass in the string, you have to define the qualifier annotation. Maybe if it's a subcomponent, it's pretty easy. You just put it in the enclosing component. But if it's a standalone component, you have to set up all the component dependencies. There's a lot to do here just to pass one string to a type. So you can do this already today with a pattern. And that pattern is the factory pattern. Instead of injecting the presenter directly, you have a factory which you inject, and the factory takes in the dependencies of the presenter, and then it has a method that you can call with that user ID where it creates the actual presenter. So Dagger is used to inject the factory. It doesn't need to know about the user ID, and then anyone injecting the factory can create the presenter. And so this becomes better at the use site, where we have the user ID, we inject the factory, and we just call create. Now we don't need to know about that, which fields we have to set or what special method we have to call before we can use it. We can't get a presenter in an invalid configuration. We can only get a factory, and then the method is like requiring us to supply this user ID before we get the presenter. But this is verbosity and boilerplate. And it's error-prone boilerplate. So to start with, in this example, if any of these dependencies aren't scoped, meaning they aren't like singletons, this will actually be incorrect because your factory will get one instance of it, and then every presenter that you create will reuse that instance when actually you meant to maybe create an avatar renderer each time it's requested. Instead of keeping that object around, one gets created each time. And so the way you do that with these factories is you actually need to inject a provider of all of them and then call get, adding to the verbosity. This is really important because if these types change from being singleton to not singleton and you forget to do this in your factory, you're going to get these really weird bugs that are hard to reproduce because they only manifest when more than one presenter is created. Beyond that, this is just an error-prone pattern. So if you have, in this case, we have fairly descriptive types that are unique. But if you have more than one injected instances of a type using something like qualifier annotations, you can very easily accidentally reverse the order of the arguments that you pass to the constructor. And also the name is just repeated a few times, very easy to get wrong. And I'm showing this in Kotlin for a reason, because if we switch to doing this pattern in Java, it doesn't fit on a slide. Look at how many times each of the dependencies shows up. You have the field, you have the constructor argument, you have the constructor statement to set the argument to the field, you have the factory, which has a provider field, its constructor arguments, its constructor statement, and then using that provider in the create method. There's 7 references to every dependency in this file. 7 chances to screw up the naming, to screw up which are being assigned, and yes, the compiler and the type system is going to check you a little bit, but this is code that is, in the very definition, boilerplate. So, going back to Kotlin so things will fit on the slide, there's solutions for this. We don't have to write, you can write this factory if you only have maybe 1, but if this is a presenter and you have 200 screens in your app, this is going to start adding up and costing time and potentially creating bugs. So this is more like what we would want to write, where we just declare an interface for the factory and the argument it requires. Now, Juice actually did this, and they called it assisted injection. And it allows you to just define this factory as an interface. You still put @inject on the constructor, but any arguments that are coming from the factory, you then annotate as assisted. And so by registering this with Juice directly, it's going to allow you to inject the factory, and it will supply the types that aren't assisted for you. You are assisting Juice in creating this object by supplying things it doesn't know about. But this is Juice, reflection, bad on Android. Google has some code generation helpers for things that are similar to this. There's AutoValue, which lets you write value types based on an abstract class. Something called AutoService, which lets you generate service files if you're writing an annotation processor or using a service loader. There's actually a third library in that repository called AutoFactory. The way this behaves is you actually don't write anything at all. It's going to generate the entire factory for you. You annotate the types that are provided by the graph, not the ones that are assisted, so it's the opposite of what Juice was doing. And so this seems like a win, right? Now we're writing basically nothing. But I want to take a little closer look at the implications of the fact that it generates everything for you. Well, first of all, why are we annotating the things that come from the graph and not the things that are assisted? The things that come from the graph are going to be much more, in terms of quantity, there's going to be more in every object you're injecting. And so we're writing a bunch of annotations for the things that we know are coming from the graph, which means just more work. The factory itself is a generated type, and this is the type that you, as the consumer of this, will have to reference when you inject it. And if you've used other libraries that require you to reference generated code directly, this means everyone consuming your factory is going to be referencing a generated type. So if the annotation processor finds an error, that error is going to get emitted and the type won't be generated. And then all the other code referencing that type will then also have errors. And so the one little mistake that you made somewhere in Dagger is now going to get lost in a sea of other compilation errors. There's an Android tool that causes this as well, which I won't name by names. But Dagger itself also has this problem where you reference the generated type. But you only do that once. In this case, it would be for every factory. The last thing is this has been a library for 5 years, and it's had 5 releases over the 5 years, and they're all 1.0 RC 1 through 5. It's fairly stable, but that, the management of, I've made fun of how the auto libraries are released in the past, but it's just really weird that it hasn't hit a 1.0, and I don't know what the reason for that is, but that could be something that might potentially scare people off. Anyway, I want to go back to seeing whether we can find something between these. I'm not here to talk about AutoFactory. I'm actually here to talk about a different library. And what it does is it retains the ergonomics of what Juice did, which was we write the factory ourselves. But we can't use @inject on the constructor. We have to use a different annotation. So the annotation is assisted inject. And then just like Juice, we only annotate the assisted parameters. We also annotate the factory just to be explicit. This could probably be inferred. I don't know. The library, simply enough, is called assisted inject. And what it's going to do is generate the factory for you, that code. This is in Java. It's going to generate the code that you would have written that I showed on the earlier slides. This implements the factory that you have written, but it writes all this boilerplate. It has an @inject constructor. It's not scoped, so you can just @inject this without having to tell Dagger like what scope it's in. So this, we get the performance of code generation. We get the compile time safety because Dagger is still going to be checking. But we get the ergonomics of Juice, which don't require you referencing generated code from your code. That's basically the trade-off we make here. Auto factory, auto value, one of the principles of auto value is that you never reference generated code outside of that auto value type. Your consumers never see the generated type, which is a little weird that auto factory takes the exact opposite stance, where your consumers do directly reference a generated type. But there's a problem here, though. The generated factory has that inject on it, so you can inject it anywhere without telling Dagger, but it's still a generated type. It's not our factory, it's the generated one. So Dagger has a mechanism that allows us to tell it to essentially alias these things to be the same. When I request a presenter factory, I actually want you to look at this other type and supply that. And since it's an interface and implementation, this all works. That's what I just said. And then in your component, you add this, and it doesn't cause any code to be generated. It just informs the compiler that when someone is asking for the factory, actually use the generated factory. But this sucks, right? Like we just traded that manually written factory boilerplate for now writing a module boilerplate. Every factory we have to go and bind it ourselves. This is another step. There's actually two ways we can solve this, and I'm going to show you the way that we've solved it now and tease one that is better and will hopefully come in the future. The way that this works is you just pick a module that's in that project, that Gradle module, or your compilation unit. Annotate it with a sysded module, and the annotation processor will take care of generating all these binds for you. And then in your module, you just include the one that's generated. And this is very similar to how Dagger works in general, where there's only one bridge into the generated code. You write a component, and then you reference, the Dagger or my component or whatever, and that's the only bridge, and then everything else is your API, and the implementation totally separate. And so that's kind of what's going on. That's how you can think of this. This is the one bridge you have to make into the generated code directly, and then everything will just work. So the second option, how many people are using dagger-android in their app? Okay. So dagger-android is a thing that allows you to inject Android components, activities, services. And the way that you do that is just calling this Android injection in one of those components, and it will do members injection, which means it looks at the fields and the methods. The way that this works is that you write a module, and in that module you say, you write a function that has the type that returns the type that you're injecting, the activity. And you have a contribute to Android injector annotation. You're basically telling Dagger that, hey, I want you to contribute an implementation that knows how to inject this type that I'm returning. And nothing actually uses this method. Again, you're just informing the compiler of something. And then in your app component, you reference that module, and now this will work. Dagger is going to generate a module for each one of these methods. This is a little weird because we wrote a module that had nothing in it, and Dagger generated a module, and those don't link together. Nothing is linking the generated module back to the module that we installed into our component. This seems like it would be a good feature for our use case, the factory use case, where these binds methods in a module are just automatically honored by Dagger. And the reason they can do this is because they're Dagger. They get to cheat. They are the people providing this functionality, and so they get to write both sides, the runtime that has the annotations and the behavior that we want, but also the compiler, which just knows how to look up these generated contributes modules. So thankfully, did that blind you all? Thankfully, one of the developers of Dagger is very open to the idea of making this available to libraries. Libraries will be able to generate modules that are probably have completely unscoped bindings to allow you to do things like, to allow Dagger to pick them up automatically. And so this is a library that's actually a couple years old, that's had a few releases that you can start using. I wrote it like when I was at Square two or 3 years ago at this point, and it kind of sat dormant for a long time, and I just picked up development on it a couple months ago. It's at a 0.3 release right now, but this is kind of like a 1.0 release candidate. The reason I don't want to actually release a 1.0 release candidate is because I'd like to wait to see where that Dagger second option goes, and hopefully integrate that before actually doing a 1.0. But it's available and works in both Kotlin and Java. So that's the presenter side of things, and you may not actually be using presenters in this fashion, but I hope the idea of a type that's injected that you have to like sneak other state into resonates a little bit, because that it may not be presenters that you see that pattern in, but you probably have something in your app that works like that, and this is a way to restore some of the safety back to its API. So we covered the presenter. Another place where this happens, for better or worse, for worse, is injecting things into views. For whatever reason, we like putting dependency types directly into views. And the way we do this is exactly the same as we did with the presenter. Have a late init, or you have a initialized function that you call and pass in some of the dependencies before you can start using the type. Now, if you think about it, a lot of the Android widgets are like this as well. Can you use a recycler view without a layout manager? Can you use any adapter view subtype without an adapter? There's lots of Android views that have this pattern, and so it's very easy to just ignore it and say, well, it's the same as they're doing. And so you have to make sure you set these things before you do anything on the view, exactly the same as these Android views. And so from the presenter perspective, we have to remember, just like the consumer of the presenter had to remember to put the user ID in, the implementer of the presenter that's attaching to this view, or however these things get linked together, has to remember to set these things before interacting with it. So we have like layering violations here. The presenter shouldn't really know about these things. We have, again, the problem where the dependencies aren't explicit in the API. Nothing is forcing you at compile time to remember to set these. What we want is these to just be requirements in the API. This would prevent this view from ever crashing because it was missing an image loader. And if you add another dependency to a view, it would make all consumption sites fail to compile until you added that missing dependency. And this would take the responsibility off the presenter from remembering to set these. So if we look at this, it looks kind of familiar, right? Wouldn't it be nice if we could have something call this view, fill in the things the graph doesn't know about, while the view is being inflated? So you probably used layout inflator, but you may not know that there's an interface inside layout inflator, nested in layout inflator, called factory, which allows you to implement something that knows how to return views based on the name that's coming from the XML file. So every time layout inflator is inflating a node in the XML entry that's, Android widget button, it's going to call this. Or com example my widget, it's going to call this. And so what we could do is implement this factory, and then when our view that we're writing is being inflated, we could figure out how to construct it and then return it, skipping the need to go through reflection, but also enabling us to move the dependencies into the constructor. And then if we don't know, we just return null, and you fall back to the existing behavior. So this looks familiar, right? We have dependencies coming from the graph. We have things that we want to supply based on at the call site. If we annotate these as assisted, maybe we can use that same mechanism. go through the motions of writing the factory. This gets generated. We inject, we change our factory from being created to now allowing Dagger to create it. So this way we can just start using our factory in here, and Dagger will connect the dots. And then we just call the factory whenever it's our view type. Now you can construct or inject views, for better or worse. No reflection here. It's safe through ProGuard. But this doesn't scale super well. Imagine, if we have, again, 200 screens, we're going through and creating a layout inflator factory with 200 conditionals. Not the worst thing in the world, but again, going back to boilerplate. What would be ideal here? What would be the optimal implementation if we had to think of one? Well, this looks like a map of some string that's being inflated to being able to create a view, a factory of views. And then instead of having a bunch of conditionals, we would just look up a factory in the map, and if it was there, we would call create, and if not, it would just return null. So we need some view factory type that all of our factories can implement, which we can write. And then we can go back to our view factories that we've written manually and have them extend. But then we need to get them into that map somehow. And so we write a module, and Dagger actually knows how to aggregate bindings, which are the things in the graph, into collections, either sets or maps. And so we can say, whenever I want you to know about this profile factory and interpret it as the generic view factory, but we don't want it to just be a one-to-one. We want it to go into a map. We want you to create a map. And so this is just the value in the map. We also need to supply a key, and you do that through annotations. So what we're telling Dagger is create a map from strings to view factories, and this is an entry. And then we can have a bunch of these. For every view, we can write another binds. But now we're, again, back to the same old thing where we're now manually writing a bunch of stuff. We're just moving the boilerplate around. Instead of writing the factory implementations where they're generated, instead of writing the conditionals, which is boilerplate, that's now a map, but we still have one thing for every view that we have to write. And also this factory is kind of useless now. Doesn't really convey a lot of information that we can't get elsewhere. It's a factory that returns a profile view, and then everything else is standard. It's always the same two arguments. And we don't actually care about the return type because we're aliasing it directly to view factory, and view factory only cares about view as a return type. So this factory that we have to write, even ignoring the module, also redundant. Well, in order to solve this, we can use the same trick that we've been using, which is code generation. So there's a different annotation allowing you to have the factory be generated without writing the interface and implementing the view factory that we already know about. So this is what gets generated. Implements the view factory type. That type that's defined, we defined as the generic thing that takes a context and an attribute set. And then the implementation comes from just whatever view is annotated. Calls the constructor, and then does all the factory stuff we saw before. And we can do the same module trick. Instead of writing binds, why don't we just generate the module? So we include that, potentially in the same one, add it to our component. And now even this factory is kind of useless, right? This is the same for everyone. Everyone wants to request a map, and they want this implementation. And so let's just move that into the library as well. And so the way this works is that you have your presenters that you're using assisted factories on. You have your views that you're using inflation factories on. And you can pull this into, say, an activity, inject the inflation, what's it called? Inflation inject factory. This comes from the library. It's going to request a map of string to view factory. Dagger is going to aggregate all of your generated inflation injection factories. Yeah, no one said these words were, these terms were terse. And then you're going to just set the factory, inflate your view, get your ID from the intent, create your presenter, and hook the two together. Now, this looks like another place where I can continue going down running through this exercise, because this is glue code, where we have a presenter that's a type, we have a view that's a type, doesn't actually have to be a view, could just be like a binder for the UI. And we're hooking the two together, we're creating the presenter with its factory. Like, there's repeated code here. But going farther than this starts to move out of library and into framework space. It's architecture at this point, and architecture is very specific to individual apps, and so it's hard to create something reusable here. And so I'm going to cop out and just say that this is the exercise left to the reader. But what's nice, one thing I do want to mention is that we've been getting rid of latent nits, or if this was Java, just fields that we have to set before we can use something. And there's still latent nits in this activity. Can we get rid of these as well? Can we move all the way up the stack and have no latent nits? Sort of. You can do constructor injection on activities, only on API 28 and above. So maybe droidcon London 2022, I'll be up here talking about the next version of this library allowing you to do activity injection. Actually, I do hope to add this to Dagger directly so that it just works. And then in the lovely future, when we're all min SDK 28, it will just be there waiting for us. Inflation injection is actually part of assisted inject. They're not separate libraries. So scroll down a little bit, you'll see the modules are actually in there. They're both in there because there's almost nothing in inflation injection. It's like one annotation, the view factory, and then even the annotation processor just delegates to the assisted injection to it's generating the same factories as assisted injection. Same versioning. So you can use that today. It all works. Actually, the Square Cache app is using just assisted injection. They plan on using view injection as well. Okay, Dagger, assisted injection, inflation injection. These are all annotation processors which come with properties that we like. Compile time safety, runtime performance, ability to ProGuard without special rules. But there's cost to that, and that cost is build speeds. When you go in your IDE and you have all these things implemented, especially if they're in Kotlin with KAPT, you click your run button, and then you just wait. You wait, and you wait, and you wait. Because not only does compilation have to happen, but these annotation processors have to run, they have to generate source code, that source code has to be parsed, compiled, written back out to the file system, dexed, apt, zip, adb. There's lots of things here. But the annotation processors, while getting rid of them is not going to solve everything, it's going to make this at least a little faster. And so there's ways to make the use of Dagger faster. When we analyzed Dagger on an app, we found that approximately 40% of the time was spent formatting the generated code. So it's using this library called Java Poet, which generates mostly readable Java code, but they were running it through a formatter so that it would look in a consistent style. And this is 40% of the time of Dagger, not 40% of the build, 40% of just what Dagger is taking. And then actually the blue stacks underneath the red ones that I've left are the I/O time. So really the time like in the CPU is here, but the blue is just reading and writing the generated code to the file system. Thankfully, as of Dagger 2.18, which was, 2 weeks ago at this point, there's a way to turn this off. It's not the default. It would be nice if it was opt-in for people that wanted the formatting, but currently it's opt-out. And so in your root build Gradle, you can just set this on all projects and say, don't format the generated code. You're just wasting time. And if you're using KAPT, you got to do something a little different. In Gradle 4.7, which was a couple months at this point, they have written an extension to the annotation processing APIs that allow it to be incremental. It is not currently incremental in regular Java-C. And so it needs to see all the classes, like Java C can be incremental, but the annotation processors can't be. And so Gradle has built their own API for doing this. And Dagger 2.18 also added support for that. Again, opt-in. This one potentially has a very strong likelihood that it will be enabled by default in the future. Now, incremental annotation processing is great because it's just going to reduce the amount of time spent. And so if this is us compiling, this is like a timeline, not just a blue box. And the yellow is the time spent in the annotation processor. By doing the annotation processing incrementally, we're just going to reduce that time to some subset. Doesn't really matter, as long as it's not more. Any gains here are going to be like free. It's a free win. Like this, your builds just got faster for free. And then Java C and Kotlin C also have ways of being incremental. And so the amount of compilation that you're doing is also going to be reduced. And so we're getting to a point where you might see something like only 30% of the time taken in the compiler compared to before. And so I don't want to dismiss incrementality as something that shouldn't be focused on, but what I want to do is I actually cannot overemphasize how much modularization is also a huge win here. Because with smaller compilation units, the amount of time spent in each compiler is a lot smaller. The annotation processors then have to process less code. It also means that the work can be parallelized. Right? You have a CPU with multiple cores, and compilers are single-threaded. And so now we can share this work. And the wall clock time, this is not free. Like, this is still expensive work. Modularization, especially correctly, is hard. But the gains are huge. And they get even better when things like compilation avoidance comes into play, caching, downloading caches from distributed servers. And so you can take the wall clock time that you spend in a build and actually significantly shrink it. Both of these things are things you should focus on, but you can't just enable a flag for modularization. It's not just a little one-liner. That's a lot of work, but it pays off. And so yes, incremental is great, but also it doesn't reduce the need to modularize. And so we're still, this will never be fast enough. There is no such thing as the fastest Gradle build. And so what if we thought a little bit outside of the box and said, well, maybe we could avoid annotation processing altogether. I wrote a module in a library called Butterknife, also an annotation processor, which is 100% reflection, which is a little weird, especially if you know Butterknife and have understood why it existed 5 or 6 years ago whenever it came out. It's a little weird to say, now we're using reflection. Reflection is a lot faster on Android nowadays, but still not something you probably want to do. The reason this exists, though, is for that IDE experience. Do we really care that the app is 5% slower when we're running it from the IDE as compared to from the command line? If your APK shows up, if your app shows up on your phone, seconds, 20 seconds, 60 seconds sooner because no annotation processing happened, I don't mind a 5% performance hit. The way that Butterknife gets away with this is because it has a single API that you call through. You don't reference the generated code directly. You call into Butterknife, and it does a class 4 name lookup of the generated code. And so it's very easy to create another implementation of the library that just does everything through reflection. No generated code. And then in your Gradle file, you say, am I Gradle being run, like synced from the IDE? And if so, don't add the annotation processor, don't add the real runtime. Use this reflection implementation. If this is your only annotation processor, annotation processing won't run. Your Java C can be incremental, can't be incremental with annotation processors. Your Kotlin C, also incremental, KBT, doesn't have to run. The reason we don't do one caveat here, 2 caveats. I wouldn't do debug and release. You could do debug and release. It's still nice to have the annotation processor run on CI builds or command line builds just to make sure you're doing the right thing. There's checks in the annotation processor that aren't in the reflection runtime. And the other caveat is, I haven't actually tested this. I don't know. So I know people do release builds from the IDE. Just don't ever do that. Run them from the command line. But I think if you do this, it will use the reflection in the release build because it's from the IDE. So I don't know. I kind of forgot about that when I wrote the README, so I should probably put something in the README about that. Anyway, I'm not talking about Butterknife, I'm talking about Dagger. Dagger is mostly annotations, interfaces, and can we do something at runtime that knows how to read annotations on interfaces? Well, I know a guy who works on a library that does something very similar to that. Maybe we can reuse some of the patterns from that. The other part is we access generated code directly. There's just this one bridge, but it's important to note that with Butterknife, we weren't doing this. It was always a library we were calling into, and we can swap out the API behind the scenes. With Dagger, we don't have that. We jump directly into we link directly to generated code. So this is going to present another challenge. Let's start with the first part. Can we just get Dagger reflect as a thing? Well, we can just have a factory method which takes the class, and then the way that you implement interfaces at runtime is through this thing called a proxy. You don't really need to look at this. But we just have an object that it essentially just has it's like a single method callback that every time you call a method on the interface, it's going to call your callback with like the name of the method, the arguments, and it allows you to return whatever you want. That's how retrofit works. We can do the same trick for Dagger. So you don't need to know about the implementation. Create's there as well. That part's kind of easy. Then you just do reflection on all the annotations. You look at the modules, you look at their methods. That part is actually not at all hard. And then you put it in a graph, and a graph is kind of just a map. The hard part of trying to get this working is this part. How do we swap this out where there's no annotation processing anymore? Well, one trick to just get it faster is we can still do code generation, but the generated component is just going to call into that reflection thing. And so this annotation processor should be blazing fast. We're writing 3 lines of code out to the file system and then compiling it and whatever. You know, not at all slow, but still having to run through the annotation processor. And then we do the same for create. And so this looks a lot like Butterknife. We now have the implementation of Dagger that is crazy, that the compiler generated, the real compiler. And then we have the one that's a little weird, which is doing everything through reflection. And so this, as long as the code generating is source compatible, unlike Butterknife, which had to be binary compatible, this only has to be source compatible. It doesn't really matter. It's really easy. You can run your app with a reflection version of Dagger. This is a little side project I have. They look exactly the same. This looks dumb. I probably actually used the same screenshot twice. But I promise that it actually works. You can run, only part of the app is running through Dagger Reflect, but it totally works. Binds works, provides works, static, abstract modules, components, component builders, binds instance. Things that don't work yet, subcomponents, and map bindings. But it works. And I could not tell, like this is a really simple app. So performance is like through the roof because it does almost nothing. And so, yeah, I can't tell a difference. In a real app, you might see a little slowdown from the reflection. Everything is super lazy in order to like amortize the cost of reflection over the lifetime of the app running. But it works. But we still have the whole point of the Butterknife one was we wanted no annotation processing to run because the presence of an annotation processor is really the problem. It's not how fast they are is a problem, but the presence of them means there's other effects on the build toolchain that are negative. And so we can't just do the Butterknife trick directly. We can't call this because that's going to break when you compile it on the command line or in your CI. But maybe we can try and do the same trick where we write a class that has an API that calls into this reflection implementation, and there'd be one for create as well. And then for the other one, the one that deals with the compiler, maybe we just do a reflection call to the builder. So this would be like the production one on the bottom. So a little scary, right? Like we're breaking some of the things that are really nice about Dagger, which is pro-guardability. But this works. So that's one way we can accomplish this. What's nice is this works for Java and Kotlin. But with Kotlin, oh, and the important thing, no more annotation processor in debug builds. So, butter knife being used less and less every day, thankfully. Dagger, hopefully, more and more. And so the impact potential here is high. Unfortunately, this breaks the ProGuard and R8 thing because that builder method we're accessing through reflection, and so you just have to keep its name. Not terrible, but it'd be nice to not have to even think about that at all. For Java, there's really no help. Maybe R8 can rewrite the reflection to be, because it's not like dynamic reflection, it could rewrite it to just a real method call. That would be cool. There's an issue filed for that. I don't know if they're going to go for it or not, though. But Kotlin, we have some other tricks. We can, instead of calling a static method written in Java, we can write an extension function on class, K-class, really, Kotlin's class. The reflection implementation is just a trampoline, just calls into Dagger reflect. The production one, the one that works with the real annotation processing, that's the challenge. We write one that just throws, all it does is throw an exception. And so if this method actually runs on a release build, the app will crash. But the trick is that we have another annotation processor that generates more specific extensions that bind higher than the more general one. And so when the compiler is resolving which of these overloads to call, it's going to choose the more specific one that then just trampolines to the real generated code. Because this is an inline method, both of them are inline, but this is inline, so this method actually completely disappears, and the code in your APK is referencing the generated code directly. And in the IDE case, it's referencing Dagger reflect directly. So we're like, not abusing, we're like using to great effect language features of Kotlin to fix this problem of resolving two different implementations. And so this is, like I said, this is working. I showed SDK search running on Dagger reflect. Definitely not usable yet. Literally started the library Sunday of this week. It's being developed in SDK search, so there's a folder inside SDK search if you want to help or you just want to go look at it. It's there. It will eventually move somewhere else, either to its own library, or it would be great to maybe convince Dagger to just put it in Dagger itself. But that's just something to keep an eye on. I'm a little over time. No time for questions. I will be around, or you're always welcome to hit me up on Twitter. I know this talk was advanced and very niche, but I thank you all for listening.